In the video, we will be determining the forces in all the members of the given truss. So this is a truss, right? So in this truss, you have to find the member force in all these members. At first, whenever you are determining the member force or axial force in the given truss, you have to first check the determinacy and indeterminacy of the given truss. So let us try to check the degree of static indeterminacy of the given truss. That will be given by m plus r minus 2j, right? So what is the value of member? So a 2 3 4 5 6 7 8 9 10 11. So 11 members. Reactions are how many? So this is hinge support, this is roller support. In hinge support there is 2 reactions, unknown reaction, and in roller support there is 1. So that will be 3 minus 2 into joint. So what are the number of joints? How many number of joints? A 2 3 4 5 6 7. So right, so there are 7 joints. So 14 minus 14 is equals to 0. So since degree of static indeterminacy is 0, so it is a perfect truss, right? It is a perfect truss and it can be solved with the help of available equations, that is summation of fx is equals to 0, summation of fy is equals to 0, and moment about any point is equals to 0, right? So another task is to determine what is the support reaction. Now look, so this is, you have been asked to determine the forces in all the members, right? So which method to use? In this case, you have to first fix it, right? Since you have to determine all the members, you can go by the joint method. If you have been asked to determine the certain member force in this system, then you can go by the section method. Or if any method is not given in the question, you can go with the joint method or the section method. You can also use the joint method and section method in the same problem as well, so as to quicken your solution, right? So you have not been asked, if you have not been asked which method you to use, you can use whatever method you feel easy to do in the examinations, right? So you first determine this. So this is in this form, right? You can go from this way and compute them and check the reactions in this support calculation of support reactions. For that, you have to assume the reaction in this system. So this is a roller support, so let this be reaction R G X, right? Again, this is a hinge support. There are 2 reactions in this. Let this be R D X, and the vertical reaction, let this be R D Y, right? So now I will be doing here is taking the summation of moment about point D is equals to 0. Since there are more number of unknowns, clockwise positive if you take, then what will happen, right? So RGX into this distance is 4 meter, RGX into 4 meter clockwise, minus, look at this, 10 is giving at this point anti-clockwise, 10 into 9 minus 15 into 6 minus 20 into 3 is equals to 0. If you solve this, RGX will be nothing but 60 kilonewton. Yes, so the value of RGX along this direction, since it is positive, the assumed direction is along this direction, right? Assumed direction is correct. Again, if you take the summation of force in y direction, if you assume the upward direction as positive, then R dy minus 10 minus 15 minus 20 is equals to 0. Therefore, R dy is equals to, this is 15, 10, 25 plus 20, 45. So 45 kilonewton will be the reaction at D support in the vertical direction, right? This is the reaction. Now you can determine the value of RDX as well. So RGX, summation of force in x direction, plus RDX is equals to 0. Then RGX is what? 60 kilonewton. RDX is 0. Sorry, RDX then goes to 0. So RDX is equals to 60 kilonewton. This is in this direction. So what you have to write in this figure is, this is 60 kilonewton in this direction, right? This is again 60 kilonewton in this direction, right? And RDY is 45 kilonewton in upward direction. This is 45 kilonewton in upward direction. Solving by joint method. Let us see what will happen. Okay. So look, you have to determine this angle, let this be theta 1. You have to determine this angle, let this be theta 2. You have to determine this angle, let this be theta 3. So theta 1. Theta 1 is, this is base tan inverse. This is base of 9 meter. This is height of 4 meter, right? So that will be P by B, 4 by 9. So that will coming out to be 23.96 degree, right? So you have to determine this angle theta 2. For this you have to determine this height CF, right? So you can take this triangle and this triangle as similar triangle, this big triangle and this triangle as similar triangle CF, and this is DG, right? So you can determine this height CF. So this is 6 meter, this is total is 9 meter, right? So what you can determine is the CF divided by DG is equals to 6 divided by 9 using the property similar triangle. CF is equals to 6 by 9 into DG is 4 meter, right? So this is 2, this is 3, this is 8 by 3, that will be 2.67 if I do fix 2, right? Again, if you have to determine the value of BE, so similarly you can determine the value of BE, right? So using similar triangle property like this is given, you know, this is what, 4 meter, this is B and E, this is 3 meter, overall is 9 meter. So you can use BE divided by 3 is equals to 4 by 9, right? So this is 3. So implies that BE is equals to nearly equals to 1.33 meter. Height of BE 1.33. You determine the height of CF as what? This is 2.67 meter. Okay. Now, so in this figure, now you can easily determine the value of theta 2 and theta 3 using this angle transformation. Now, what is theta 2? That will be tan inverse this triangle. Use this triangle, right? This triangle, that will be tan inverse 2.67 P by B is 3 meter. So that will be 41.67 degree. Again, theta 3 will be tan inverse. So theta 3 is this, right? So this is P is 3 meter and B is 3 meter and P is 4 meter, right? So that will be 4 by 3. So that will be, so you determine theta 1, theta 2, theta 3, right? So theta 1 is nothing but 23.96 degree. Theta 2 is nothing but 41.67 degree. Theta 3 is nothing but 53.13 degree. So how can you use joint method? Let us see. Adjoint A. So why you are using adjoint A? Since when you are standing adjoint A, there are two unknowns. Two unknown can be solved with the help of two equations. That is summation of Fy is equals to 0, summation of Fx is equals to 0. So let us try to make the figure. So this is joint A. This is member force FAB. This is force in member AB. Axial force in member AB. This is FAE. I am assuming the forces to be tensile, right? If the assumption is wrong, the force will be coming out to be in the compressive side, right? So this angle theta 1 is 23.96 degree. You have to write this thing as well. 10 kilonewton is the downward force at joint what? A. So use the equilibrium equations to find the value of FAB and FAE, right? So if you use the equilibrium equations, then so at what I'll be using is summation of force in y direction is equals to 0. Then FAB sine 23.96 is equals to 10 kilonewton, right? So FAB will be 10 by sine 23.96 degree. So that will be nothing but 24.62 kilonewton. This is tensile, right? So this is tensile force. What this is positive. Since it is positive, the assumed direction of axial force along AB member is in the tensile side, right? In the tension zone. Okay. So adjoint. So this is adjoint A, and you have to find the FAE as well. So taking summation of force in the x direction is equals to 0. What? FAB cos 23.96 degree plus FAE is equals to 0. Then if you solve this, the value of FAE will be negative. FAE is what? 24.62 cos 23.96, right? So if you do this, the value will be coming out to negative 22.50 kilonewton. This means 22.50 kilonewton. The nature of the force is compression. So this is 22.50 compression. You have to use this. Since you assume the direction has to be tensile, it is coming out to be compression, right? So you have to use this sign for further calculations, and you have to use the nature compression, right? You have to understand that thing. So at joint A is over, you have to use this value in further calculation, right? So I'll write this. AB force is what? What is the AB force? 24.62 tension. AE is nothing but 22.50 compression. 50 compression, right? Negative, I will write this. So you determine two aspects from joint A. Again, you have to determine other member force from other joint, right? When you go to joint B, there is 1, 2, 3 unknowns, right? 3 unknowns and 1 unknown AB. One value AB is already determined. So there will be BC and B unknown. 2 unknowns. 2 unknowns can be solved by 2 equations. Okay. If you have been going through joint E, then 1, 2, 3, 4. So there are total 4 forces and 1 force is already determined. So there are remaining 3 unknown forces. 3 unknown forces cannot be solved by 2 equations, right? So you have to go, obviously you have to go at the joint B. So at joint B. So write whatever the figure of joint B suggests you to do. So this is the figure of joint B. So I make this horizontal direction. This is 23.96. This is 23.96. So I am making tensile direction like this, FBC. So let this be force FAB, and let this be your FBE. So this is, I draw the joint B and draw the member forces in this system. I assumed all the forces to be in tensile nature, right? So you assume this thing, and you have to use the values that have been computed in the sign. Whatever the sign is computed, you have to use in this thing, right? So there is no any external forces, so you need not to write this, right? So if you take the summation of force in the x direction, then it is clearly seen that FBC cos 23.96 is equals to FAB cos 23.96. That equivalent to, if you got this, FBC is equivalent to FAB. So FABC is equals to AB, 24.62 tensile, right? So this have been determined easily. So use the equilibrium equation in y direction. Then FBE, if you take downward direction as positive, FB plus FAB sine 23.96 is equals to FBC sine 23.96, right? So there is the case, FB is equal, you subtract this value are equal, so FB will be coming out to be 0, right? So this is a zero force member. FBE is zero force member. How do you recognize that? By doing these calculations. On the other way around, you can determine the value of FBE at 0. So what we have understand in the class is that whenever there are 3 member forces, right, like this, there are 3 member forces like this. This is one member, this is another member. This is collinear. 2 members are collinear and one is not non-collinear. Then in this case, the non-collinear member is the zero force member. What is the case? That whenever there is no any external load at the joint. If there is no any external load in this joint B, this member is collinear and another member is non-collinear, then the non-collinear member is always a zero force member. So these have been verified by this assumption as well. So you can determine as quickly as possible using this assumption as well, right? Okay, next. So what at what joint you have to go at? Look at the figure and decide accordingly. So if you go at joint C, what will happen? If you go at joint E, what will happen? So if you go at joint D, there are 4 number of forces, among which there are 2 are already determined and 2 will be unknown, can be solved. If you go at joint C, 1, 2, 3, 4. So there is 1 have been determined and others are not Others are not determined, so 3 unknown, so that cannot be solved. So why? So at first you have to go adjoint E. So this you have to understand it. So adjoint E, what is the case? So draw the figure adjoint E. So this is the case here. Okay, so this is joint E acting, there is 15 kilonewton point load. I am making all the forces to be tensile. F, EF, this is F, EC or CE, I write EC. So this is FBE, FBE, and this is FAE. Since the value of VE is 0, it is not mandatory to write that. So the FV is 0. No need to write the member force in the BE section, right? So this is a 0 force member. So now, right, 1, 2, 3, 4, 1 is gone, right? So what is the angle? This is 41.67 degree with respect to horizontal, right? So if you take the summation of force in y direction and upward direction is positive, then FEC sine 41.67 degree is equals to 15, right? Then FEC will be coming out to 15 divided by sine 41.67 degree. So what is the value of FEC? You can write it. 6 tensile, 5, 6 tensile. So FEC is 22.56 tension. So if you take the summation of force in x direction, then FEC cos 41.67 plus FEF is equals to FAE, right? So you determine the value of FEF in this case. AE is nothing but 22.50. EC is 22.56, that is minus 22.56 cos 41.67 degree. If you solve this, the value of EF will be coming out to be 39.35. 39.35, that will be coming out to be 39.35 compression. 39.35 kilonewton compressive, negative, right? So this will be the value of EF. So what I'll be writing is the value of EF as 39.35, right? So it will be 39.35. FEF will be 39.35 negative, which is compression, right? Okay, so adjoint E is over. Now you have to go at C and F, or F or C. If you go adjoint C, there will be this have been determined, this have been determined, this is to be found, this is to be found. So 2 unknown, right? So you have to go at joint C. So look, you have to draw the figure of joint C. There are four forces in this case. This is FCD, this is FBC. I am drawing the horizontal line here. Let us draw a horizontal line in this case. Okay, this angle is what? We draw this. So this angle is, right? So this angle is 23.96 theta 1, and this angle is what? Total angle is theta 2 with respect to this. So this is 23.96, and this angle is, this is FCE, right? Or EC. EC, this is 41.67, right? There is no any external force here, and this is what? FCF. Okay, and CD is oriented at 23.96 degree. So this is the free body diagram at joint C, right? So in this case, what you can use is, look, FEC is determined, FBC is determined, you have to determine these two forces, right? If you use summation of force in the x direction, then CD will be determined. If you use summation of force in y direction, then the FCF will be determined, right? So I will try to determine both the forces, FCD and what? FCF. So I will be using summation of force in x direction is equals to 0. So if I take this positive here, FCD cos 23.96 will be is equals to the sum of FBC 23.96 cos 23.96 plus FEC cos 41.67 degree. So look, this have been determined. FCD is equals to FBC. BC is what? 24.62. 24.62 cos 23.96 plus FEC. EC is 22.56. 22.56 cos 41.67 divided by is cos 23.96, right? So this is positive this, so the value will be coming out to be obviously positive, so that will be 43.06 kilonewton, that is positive, so tensile. So CD is 43.06 tension, right? Okay, so again you have to determine CF force. Okay, how to determine the member force in CF? Take the summation of force in y direction is equals to 0. There are most of the forces are in downward direction. Why not to take the downward direction as positive? So then this will be CF is downward plus FBC downward sine 23.96 degree. So FEC plus FEC sine 41.67 degree, that will be equals to FCD sine 23.96 degree, right? So if you solve this of FCF will be coming out to be 0.51 kilonewton. This is negative, so compression. Okay, so this is the way you can solve the member force in CF and you determine the value in CD. Now what you can go at joint F, at joint D and at joint G are remaining in this case, right? So let us try to make that thing. So at which joint I need to go? Now you have to give the answers, right? If I go at joint F, 1 2 3 4 forces, 2 have been already determined, 2 are remaining, you can easily find. If you go at joint D, 1 2 3, right? So this is fine. You can also find at joint D, you can find these forces. If you go at joint G, so these are remaining, so you have to go at, you can go also at the joint G, right? If you go at joint G, these forces and these forces will be determined. So at first you need to be sure that which joint you have to go at, right? So here I will be going at the joint F and compute, check at D and check at joint G, right? So at joint F, so what will be the figure here? This is the figure, okay, joint F. So 1 2 3 4, 1 2 3 4, right? Yes, F, FG, F. This is F, CF or FC, CF or FC, CF. This is F, EF, right? So there is 20 kilonewton at this joint, so do not forget to write this thing. So this angle is 53.13 degree. This is theta 3, you determine it, right? So this is, so taking the force in y direction and taking the force in x direction. So if you take the force in y direction, what will happen? F df sine 53.13 plus FCF, right, minus 20 or is equals to 20. So F df sine 53.13, FCF is minus 7.51 is equals to 20, right? So if you find this, the value of FDF will be 34.39 kilonewton. This is positive value, so this is tensile. So FDF is equals to 34.39, right? So 34.39 you have to use this and you have to find FG, right? So using the forces, summation of force in x direction, FG plus FDF, this is cos 53.13 is equals to FEF, right? So what is the value of FG? This is unknown, FG is unknown, plus FDF you determined it recently, that is 34.39. This is tensile, you have to take positive. Cos 53.13 is equals to FEF. EF is what? You have already determined, negative, right? Negative 39.35. Negative 39.35, right? So what? FFG will be negative 39.35, negative 34.39 cos 53.13, right? So it will be coming out to be near, so FG will be coming out to be near about 60 kilonewton negative. This is negative, so what is compression? Look, so FG value will be negative. right? So you can check this value by going at the joint G as well, right? For check. Okay, let us try to check this thing. Determine the member force in FG. You have determined FD or DF. You have determined CD. One thing is remaining, that is D, G or GD, right? So I will go at joint G. You have to go at joint G. So at joint G, what is the case? Look, this is the case. FGD, this is FG. There is 60 kilonewton like this, right? There is no any external load in the downward direction, in the vertical direction. There is only horizontal direction in force. So here FG is plus 60 kilonewton is equals to 0. Therefore FG is negative of 60 kilonewton. Look, you determined FFG as 60 kilonewton already. So this is compression. So it have been checked. Your solution is completely right. This means like this. Again, so now in a vertical direction, look, FGD is equals to what? FGD is GD is 0, right? No any force in this GD. I will be checking the member force in other members as well. Let us see. At joint D, right? Look, this is your joint D. This is your assume direction. There is a 60 kilonewton force here. So there is a 45 kilonewton force here. Now, so this is F, CD, this is F, DF. What is this? This is F, D, G. Okay. So now, this is angle what? This angle is what? Look, this angle is CD, so it is 23.96 degree, and this DF angle, right? DF angle is what? This angle 53.13. So this angle is 53.13 degree. Okay. So now what you can do is, if you have to take the summation of force in upward direction, right? If you take the summation of force upward direction, what the value of FD will be coming? You can check this, right? So this is for the purpose of checking. So let us see. So if you do the summation force in y direction, if you take the downward direction as positive, then FDG plus FCD sine 23.96 degree plus FDF sine 53.13 degree is equals to what? How much the value will be? To 45, right? Put CD, the value of CD as 43.06. Put the value of DF as, what is the value of DF? 34.39. So 34.39. So it will be coming out to be, if you subtract it with 45, then the value will be coming out to be 0, right? So the value of FDG will be 0. So you checked it twice, right? This is absolutely correct. Okay. If you want to check the value of these two forces or either of the forces, you can do as well. This is for the checking purpose. Okay. So FDG is 0. So I can replace this FDG value. Okay. Now, if I put the value of DF and if I have to get the value of CD, I can get this as well. So like, let us see one thing and we'll be closing our solutions for today, right? So this is 60 kilonewton in this direction. If I have to find only the value of DF, if the value of CD is known, right? What I can do is, so 60 is equals to summation force in this direction as positive. 60 is equals to FCD is already known. Let us say FCD is what? 43.06 tensile. So that is 43.06 cos 23.96. So this is unknown left. Let us suppose FDF. What? This is cos 53.13. So this. So what is the value of FDF? 60 minus 43.06 cos 23.96 divided by cos 53.13 will be FDF. What is the value of FDF? In this case, if solve this, FDF will have to come out to be 34.39 kilonewton that shall be in tensile. Let us check it out. The value of the FDF will be coming out to be near about 34.39. So this is the way you determine all the members and you check each and every members individually, right? So I will try to write the answers of these given questions. You have to write member forces, you have to write the magnitude of the forces, and you have to write what is the nature of the force you determine, like this. So what is the member force? AB, you determine AE, you determine again what? BE, you determine BC, then you determine EC, EF, CD, CF, DF, FG and DG. You determine these member forces, right? So what is the value of AB, what is the value of AE, BE, BC, EC, EF, CD, CF, DF, EG, DG. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Altogether there are 11 members. You find it earlier, right? So you have to just tabulize these answers in this tabular form so that it can be visualized quickly. 24.62. So it is tensile. So 22.50. A, it is compressive. B is zero force member, neither tensile nor compressive. BC is 24.62 tensile. EC is nothing but 22.56. It is tensile. EF is 39.35. It is compressive. CD is 43.06 tensile. CF is 7.51 compressive. DF is 34.39. It is tensile. FG is 60 or GF or FG. GF or FG. It is compressive. DG is zero force member. Oh, it is provided only for stability purpose. At the end, like, share and subscribe, please sibling. It is the only one way we can be motivated. Please share this video to the needy ones who are facing certain troubles in applied mechanics or engineering mechanics or whatever engineering subjects they are need to be concerned about. So thank you so much. Like, share and subscribe, please.